In section 10.6, we will look at circles and arcs. And first, the parts of a circle. A circle is a set of points equidistant from a given point. On the right, we can refer to our circle as circle A. The center is the point that is equidistant from all points on the circle. So our center is A, and that is why we refer to our circle as circle A. A radius is a segment with one endpoint at the center and one on the circle. So there are a few radii here. There's radius AG, AB, and AC. Order does not matter when we name our radius because they are line segments. A chord is a segment that connects 2 points on the circle. So ED is a chord, and FC is a chord. Again, order does not matter when we name our chords since they are line segments. A diameter is a chord that includes the center. It is the longest chord in the circle. So a diameter is a specific type of chord. Our diameter here is GC. So just 2 letters to name our diameter. Again, order does not matter when we name it. Central angle is an angle whose vertex is in the center. So referring to the same circle, our central angle here is angle BAC. An inscribed angle is an angle whose vertex is on the circle. So an inscribed angle in our circle is angle GCF. A semicircle is half of the circle. So in our circle now on the right, our semicircle is ZXY, and we have an arc above those 3 letters. So that's a new type of notation now. A minor arc is an arc between 0 degrees and 180 degrees. We'll just use 2 letters to denote a minor arc. So minor arc here is ZX, and we have an arc symbol above those 2 letters. A major arc is an arc between 180 degrees and 360 degrees. So I can say that's arc YZX. Notice how I used 3 letters to say I went from Y to Z to X. So I went that way around the circle as opposed going Y, X, Z. Adjacent arcs are arcs of the same circle that have exactly one endpoint in common. So arc YX and arc ZX are adjacent arcs. They share the endpoint X. Concentric circles are circles that lie on the same plane and have the same center. A dartboard is an example of concentric circles. The arc addition postulate says the measure of the arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So this is similar to our angle addition postulate and also our line segment addition postulate. So referring to my circle on the right, I can say that the measure of arc ABC is equal to the measure of arc AB plus the measure of arc BC. In example 1, we want to find the measure of each in reference to our circle on the right. Now, the measure of a central angle is the same as the measure of the arc that the angle intercepts. So in A, the measure of angle COD will be equal to the measure of arc CD, which is 58 degrees. The measure of arc CDA. Well, CDA is a semicircle. It's half my circle. Remember, a circle is 360 degrees, so a semicircle is 180 degrees. The measure of arc AD, well, we know that CDA is 180, and we know that CD is 58. So if we subtract those two arcs, we get that the measure of arc AD is 122 degrees. And then finally we want to find the measure of arc BAD. Well, we know AD is 122. We know BC is 32 because that arc is the same measure as the central angle COB. Arc CBA is a semicircle, so that means that arc BA must be 148 degrees. Just fix that because it has to add up to 180 with arc BC. So to find the measure of arc BAD, we will take 148 plus 122. Get that the arc is 270 degrees. Okay. Number 2 says a researcher surveyed 2,000 members of a club to find their ages. The graph shows the survey results. Find the measure of each central angle in the circle graph. All right, so we know what percentage of that population was surveyed, but we do not know the angle in our circle graph. So again, remembering that a circle adds up to 360 degrees. That's all the central angles and all the arcs add up to 360. Then we can find the angle of each of our portions here. Starting with the 65 and plus group, we will take our percent times 360. So 25% as a decimal, 0.25, times 360, 90 degrees. So the 65 and up group is 90-degree angle. Then the 45 to 64 group, so taking 0.40 times 360, we get that that angle is 144 degrees. Taking the 25 to 44 group, so that's 0.27 times 360, 97.2 degrees. And finally, the under 25 group, 0.08 times 360. Find out that that angle is 28.8 degrees. The circumference of a circle is pi times the diameter. So remember, the diameter goes through the center of the circle from one side to the other. We can use the formula C equals pi d or C equals 2 pi r. Remember, 2 radii make 1 diameter. In number 3, the diameter of a bicycle wheel is 22 inches. To the nearest whole number, how many revolutions does the wheel make when the bicycle travels 100 feet? All right, so we are given the diameter is 22 inches. First thing we need to find is the circumference of that bicycle wheel. So remember, circumference is pi times diameter. So we're going to take pi times 22 inches. And we get about 69.8 0.08 inches. Notice we want to know how many revolutions in 100 feet. So let's convert this inches to feet. So dividing by 12, we get 5.76 feet is the circumference of the bicycle wheel. All right, so let's say I'm going to use N to represent our number of revolutions. Well, 5.76 N has to equal 100 feet. So if we divide, so dividing 100 by 5.76, whoops, we get that N 17. So that means it's going to make 17 revolutions in 100 feet. So all we really did was take that 100 and divide by 5.76. You don't have to set up a formal equation there, but just so you know why I was dividing. Okay, and in number 4, a circular swimming pool with a 16-foot diameter will be enclosed in a circular fence 4 feet from the pool. What length of fencing material is needed? Round to nearest tenth. All right, so we have a pool, and we have some fencing around it. Okay, the swimming pool has a 16-foot diameter. And there is a circular fence 4 feet from the pool. So we have 4 feet here and 4 feet here. So that makes the diameter of the fence 24 feet. We have to add 8 to our 16 feet. So we want to find what the length of fencing material is needed. So we're looking for the circumference. So remember, circumference is pi times diameter. If we're looking for the fencing circumference, then that will be 24 feet times pi. And we want to round to nearest tenth. So that is about 75.4 feet. That is how much fencing we will need. The length of an arc of a circle is the product of the ratio measure of the arc divided by 360 and the circumference of the circle. So referring to our circle on the right, if we want to find the length of arc AB, so length of arc AB, that will be equal to the measure of arc AB divided by 360 times 2 pi r times the circumference of the circle. In number 5, we want to find the length of a semicircle with radius 1.3 meters. And we're going to leave our answer in terms of pi. All right, so remember, a semicircle, the arc measure is 180 degrees, and we are given our radius. So if we want to find the length of our arc, we take the measure of the arc, so 180, divided by 360 times the circumference, 2 pi, and my radius is 1.3. Let's fix my 1 there. Okay, so then length is equal to 0.5, 180 divided by 360 is a half, times 2.6 pi, taking 2 times 1.3. Now key here too is also leave terms in pi. So if I multiply a half times 2.6, I get 1.3, and we're going to keep that pi meters. In number 6, we want to find the length of ABD in circle M and leave our answer in terms of pi. Okay, so ADB is this side of our circle. We know that arc AB is 150 because it is the same as that central angle. So take 360 minus 150, we get that ADB is 210 degrees. So to find the length of arc ADB, we'll take the measure of our angle, 210, divided by 360 times 2 pi, and our radius in the figure is 18 centimeters. Again, we're going to leave in terms of pi. So length of ADB is equal to 210 divided by 360 times 36 pi. Now here we can reduce that 360 and 36 and then multiply straight across. We get that the length of arc ADB is equal to 21 pi centimeters.